Okay, so in this video we're going to have a look at an exam question involving the circle. So it's a section A exam question, 30 marks, and there are 4 parts to it. So if we look here in part 1, we're given the equation of 2 circles and they say prove that the circles touch externally. So if we have circles touching externally, then the condition for it is the distance from center 1 to center 2 will equal radius 1 plus radius 2. So if we look at our first circle, we have x squared plus y squared plus 2x minus 2y minus 23 equals 0. 2gx equals 2x. 2g is equal to 2, divide across by 2 and we get g equals 1. 2fy equals minus 2y. 2f equals minus 2, divide across by 2 again. So then f equals minus 1. So my center is minus g minus f, so that'll be 1, 1. And for the radius, it's the square root of g squared plus f squared minus c. So that's the square root of 1 squared plus minus 1 squared minus c. So my radius 1 we'll call it. Safest just to put it all into your calculator. You can do it in your head if you're comfortable, but just to reduce the risk of any error, best to put it into the calculator. So radius 1 is 5, center 1 is minus 1, 1. And then we had our second circle, which was x squared plus y squared. It's 14x minus 2y plus 41 equals 0. Minus 14x equals 2gx. You can drop your x, divide across by 2, get g equals minus 7, and then 2fy is equal to minus 2y. 2f equals minus 2, so then f equals minus 1. The center will be minus g minus f, and then radius we know is the square root of g squared plus f squared minus c. So that's minus 7 squared plus minus 1 squared minus c. And we can call that radius 2. So again, into your calculator, minus 7 squared plus minus 1 squared in brackets minus 41 will give me 3. And center 2 is equal to 7, 1. Now we go for distance formula. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance from center 1 to center 2 will equal, that's x1, y1, x2, y2. 7 minus minus 1 squared plus 1 minus 1 squared. And again, all into the calculator. And we get back 8, and then R1 plus R2 will equal 5 plus 3, which is 8. So we had 8 for R1 and R2, 8 for center 1 to center 2. 8 is equal to 8, which tells us center 1 to center 2 is equal to R1 plus R2. And so C1 and C2, the circles that they gave those labels at the start, touch externally. Okay, so that's part 1 answered. Part 2, find the equation of the tangent that touches both circles C1 and C2. So no harm here for a quick sketch. We know the circles touch externally. So I'll say maybe it looks something like that. If the tangent touches both circles, they're referring to a line. Let me draw that. A line that runs down the middle. Between the 2 circles. So it means a line like this. And then if the line goes between the two, means we have a point of intersection. So we know back from algebra, point of intersection will lead us into simultaneous equations. So we have x squared plus y squared minus 14x minus 2y plus 41 equals 0. X squared plus y squared plus 2x minus 2y minus 23 equals 0. Draw the line, change the sign. So we get minus 16x plus 64 equals 0. So then bring it over. 16x equals 64. Divide both sides by 16. X equals 4. And we know it's a straight line. So there's our answer. Okay. Next part then. Hence or otherwise, find the point of contact of the circles C1 and 2. So they want point of intersection. And we know already x equals 4. So I can pick one of the two circle equations and sub x equals 4 into it. So we get 4 squared plus y squared minus 14 times 4 minus 2y plus 41 equals 0. Tidy up your constants. That gives us back y squared minus 2y plus 1 equals 0. Guide method, factors of 1 is just 1 by 1. We need to end up with minus 2, same sign, so it'll be minus 1y minus 1y. So we get y squared minus y plus 1 equals 0, factorized by grouping. We see here we get a double answer, same answer twice. Y equals 1 or y equals 1. So then my point of contact is going to be 4, 1. Okay, K is a third circle which both C1, so circle 1, and circle 2 touch externally. Find the equation of K. So the fact we've turned the page now in the paper, it's no harm to maybe draw a new sketch. So we'd had the circle C1 and the circle C2. We know, let's see. Okay, so we know there's a tangent between them. That's x equals 4. Circle 1 and circle 2. And we know that the point of contact is 4, 1. And if my y value here is 1, so it goes on the line y equals 1. So what we're looking at here then, back to part 1. We knew for circle 1, the radius was 5, the center was minus 1, 1. So we can mark that in. Radius is 5, so radius there is 5. And then for circle 2, we had a radius of 3 and the center is 7, 1. And a radius of 3. Now for the equation of K, this circle, we see here if we add all of these values together for diameter, we're going to get 16. So then the radius will equal 8. And then the other part for us then is to figure out the center of the circle. So while this tangent may look like the center in the sketch, or 0.41, we cannot assume that's the case. What we can do, however, is find the endpoints of the circle. And if we get the midpoint of the endpoints, that will give me the center of my circle K. So to find my endpoints, I look at -1, 1, and then we're going to travel along using our radius. So if I have -1, 1, and I subtract the 5 from it, I'll get -6, 1. And if we look here, we have our center 7, 1. And I move along to my endpoint, I'll be adding 3. And that gives me the endpoint 10, 1. So we go for midpoint formula, that's x1 plus x2 over 2, y1 plus y2 over 2. We have -6, 1, and 10, 1. Into our formula then, so it'll be -6 plus 10 all over 2, 1 plus 1 all over 2. It's 4 over 2 and 2 over 2, which then tallies up to 2, 1. So my center is equal to 2, 1. And now they want us to build the equation. So a couple of options here in terms of how we sub into it. We can use, they don't specify the equation form, so probably easiest to use HK. So that's x minus h squared plus y minus k squared is equal to r squared. My center I know is 2, 1. My radius is equal to 8. So there's h and k. We get x minus 2 squared plus y minus 1 squared is equal to r squared. And just tidy up your radius. And there's our answer in the form HK. Now, if they had gone and asked us to write it in the form of a GF and C circle, well, we'd just take this here and square it out. So we'd get x squared minus 4x plus 4 plus y squared minus 2y plus 1 is equal to 64. Bring it all over to one side and rearrange x squared plus y squared minus 4x minus 2y. We'd have 4 plus 1 minus 64 will give me minus 59 equals 0. And while the equations might look different, if we were to graph both of them, we would end up with the same circle. Okay, so that's us done for that video there. Section A, short question, 4 parts worth 30 marks in total.